Hello student, welcome to Saurabh Sir classes. Today's topic, non-stationary models. Many time series encountered in practice exhibit non-stationary behavior. Usually the non-stationary is due to a trend, a change in local mean or seasonal variation. Since the Box-Jenkins methodology, if for stationary models only, we have to make some adjustment before we can model this non-stationary series. We use one of two methods for reducing non-stationary series with trend to stationary series without trend. Number 1. Use the first difference of series. It's Wt that equals to xt minus xt minus 1. Note that is can be rewritten as Wt that equals to 1 minus capital B xt. A more general form of this equation, phi p b 1 minus b to a d xt that equals to theta q b a t, where d is the order of differencing. This known as ARIMA PDF model. It's ARIMA ARIMA PDF model. And number 2, fit a least square trend and fit the Box-Jenkins model to the residual. If the model exhibits an occasional change of mean, first difference will result in a stationary model. For seasonal series, Box-Jenkins provided a modification to this equation that will be the subject of the next section. Now we are discussing about seasonal time series. Okay. To deal with series containing seasonal fluctuation. To deal with series containing seasonal fluctuation, Box-Jenkins recommended the following general model. That is phi p b p b 1 minus b whole to the power d 1 minus b s to the capital D xt that equal to theta q b, it's capital Q b s a t, where small d is the order of differentiation, small s is the number of seasons per year, and capital D is the order of seasonal differencing. The operator polynomials are phi p b that equals to 1 minus phi 1 b minus dot 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 phi p b p, theta q b dot 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 theta q bq, p b s that equal to 1 minus bs minus bsp, and the last one capital Q bs bs capital Q sq. Note that 1 minus bs xt that equals to xt minus xt minus s. Box-Jenkins explained that the maximum value of small d, capital D, small p, small q, capital P and capital Q is 2, TWO2. Hence, these operator polynomials are usually simple expression. Partial autocorrelation function. We previously discussed the autocorrelation function, which gives the correlation between different legs of series. The partial autocorrelation function is a second function that expresses information usual in determining the order of an ARIMA model. This function is constructed by calculating the partial correlation between xt and xt minus 1, xt and xt minus 2, and so on, statistically adjusting out the influence of intermediate lags. For example, the partial autocorrelation of lag 4 is the partial autocorrelation between xt and xt minus 4 after statistically removing the influence xt minus 1 and xt minus 2 and xt minus s from both xt and xt minus 4. The autoregressive order P is estimated as the lag of last large partial autocorrelation. For example, suppose the partial autocorrelation where lags and partial autocorrelation. Here 1 for 0.55, 2 0.21, 3 0.11, 4 0.72, 5 0.06, 6 0.09 and 7 0.13. We would conclude that a reasonable value for small p is 4 since the partial autocorrelation are relatively small after the fourth lag. Now we are discussing about Box-Jenkins methodology and overview. Box-Jenkins methodology and overview. The Box-Jenkins method refers to the iterative application of the following three steps. Step number 1, identification. Using plots of the data, autocorrelation, partial autocorrelation and the other information, a class of simple ARIMA model is selected. This amounts of estimating approximate values of small p, small d and small q. Step number 2, estimation. The phi's and the thetas. The phi's and the thetas of the selected model are estimated using maximum likelihood techniques, backlisting, etc. and as outlined in Box-Jenkins in 1976. The third step, diagnostic checking. The fitted model is checked for inadequacy by considering the autocorrelation of the residual series, the series of residual or error or values. These steps are applied iteratively until step 3 does not produce an improvement in model. We will now go to step in detail.